did it wrong. All right, that's fine. Okay, so, okay, we're good to go. You should have calculator out, maybe a periodic table. Okay, and I'm gonna, well, actually, you don't need the periodic table out because I'm gonna do things quickly, like use the formula masses off the top of my head and do rounded numbers like we did yesterday. Okay, so the first thing that I want to go over is molarity. Now we know, because we've used molarity, okay, in stoichiometry, that the units for molarity is what? Moles over 1 liter. Okay, and so here's what happened. I mean, like, what we're trying to learn to do is how to make a solution. All right, a particular molar solution of something. All right, and so let's say that we want to prepare a 6.0 molar solution of sodium hydroxide. Okay, well, we know in 6.0 molar solution that 6.0 moles over 1 liter. However, I can't measure moles. You can't measure moles. We can measure what? Well, we can, but we know we have 1 liter. The problem is the moles. How are we going to measure 6 moles of sodium hydroxide? We're going to convert that to grams, okay? And that's the easiest thing to do. So we're going to get the formula mass of the sodium hydroxide. So I kind of made this nice so it's just 1-to-1 everything. So sodium is 22, oxygen is 16, hydrogen is 1, and we add that up and we get what? 39 grams over 1 mole, right? All right. And so we need to use this to figure out how many grams in 1 liter of solution we need to prepare 6 molar solution. So what are we going to do? Yeah, so you're going to take the 6.0 moles over 1 liter. We're going to multiply that by 39.0 grams over 1 mole. The moles divides out, and then all we have to do is what Greg said, and multiply 6 times 39, and that would be, say that again, 234? All right, 234 grams in 1 liter. Here's the thing. You can't just take like 1 liter water and dump 234 grams in it. What's going to happen to the volume of the water if you dump 234 grams? It's going to go up, right? Okay, because you're adding more particles to that solution. So here's what you're going to do. Those are volumetric flasks that I have above that cabinet there. That's what we use to make solutions because it is pretty precise, okay, rather than using a graduated cylinder. So on those, and I didn't bring one down so that you can see, but up on the neck of that flask, there is like a little etched line. And so when you bring your volume up to that etched line, you have exactly 1 liter of solution. So what you would do is you would fill that volumetric flask half full of your distilled water. And we always use distilled water because, you know, in tap water, you have guck in it that could interfere with whatever you're using the sodium hydroxide for. So half filled with water, put your 234 grams on, put the lid on, okay, dissolve it really well, then add more distilled water right up to that line, mix it up, and you have your 6 molar solution. But problem is, we don't need 1 liter. We only need 300 milliliters, okay? So what you're going to do then is to just set up a proportion. Everything is proportional, which is real nice. And you guys know how to do proportions, right? So if we only need 300 milliliters, all right, then we would say that 234 grams in 1,000 milliliters, all right, is equal to X number of grams in 300 milliliters. And then you're going to solve for your X by doing what? Yeah, cross multiply, or really just like multiplying both sides by 300. And that will give you how many grams you need in 300 milliliters of solution. Okay. Any questions with that at all? And, you know, whenever I prepare for a lab, I mean, I'm doing this like almost every single lab. If, you know, we've run out of the solution, I have to make fresh. And because you guys are like ahead of everybody else, when I go to prep a lab, or Zach helps me prep a lab, it's like, you know, yeah, I have to make it. Then it's made for everybody else too. So anyway, this is what I go through, either making a liter or figuring out how much I need for what I need for my classes. All right, did we find how many grams we need for 300 milliliters?
That's what I got.
Is that what everybody else got? 70.2?
Yeah.
Are we verifying that? So we need 70.2 grams, and that we're going to put into 300 milliliters. Okay. So, and again, same process. 300 milliliter volumetric flask, fill it half full with your water. All right. Put in the 70.2 grams of the sodium hydroxide, dissolve it, fill it up to the line to give your, now here's the thing. If you go above that line, and that's where you have to be real careful whenever you're making this. If you go above the line, you have to start all over again, because now you're going to be less than, the molarity is going to be less than what you want it to be. Okay. But we have another conundrum. All right. We have 6 molar. I have a nice big stock bottle about the size of that glass cleaner carboy in the back, and I made up tons of 6 molar sodium hydroxide. And I did that because we use different molarities throughout the year. Okay. And so what I want to do is I want to take that concentrated solution and I want to dilute it to 0.1 molar solution. All right. So we have a dilution solution equation. I like to rhyme. All right. So we have our dilution equation, and our dilution equation is what? What is our dilution equation?
Moles of solute equals mole 1 times volume 1, which then equals mole 2 times volume 2.
Okay.
For the molarity.
And we're going to make it like this. We're going to say M1 times V1 equals M2 times V2. So this is our initial molarity. All right. This is the molarity that we want to dilute it to. All right. Your initial molarity is always the more concentrated. All right. V2 is how much of that we want. So let's say we want to make, okay, a 0.1 molar solution of the sodium hydroxide. We want to make, let's say 275 milliliters of 0.1 molar sodium hydroxide solution from 6 molar sodium hydroxide. Okay, so here's the thing. What I need to figure out is how much of that concentrated solution do I need to use and dilute it to 275 milliliters. That's going to give me a 0.1 molar solution. All right, does everybody see that? So again, like any of our other problem solving, we need to identify what our variables are. So the 275 milliliters, what is that? V1 or V2? Good, so this is V2. All right, and then 0.1 molar solution is our M2, good. All right, and so that's going to make the 6 molar our M1. All right, and again, this is something that I do all the time. All right, and you know, for other teachers in the department too, they'll come by and say, hey, this is what I need, is this what I do? And I'm just using this equation in my head to kind of verify that's what they need to do. All right, so we have our 6 molar solution. And at this point, because you have molarity on one side, you have molarity on the other side, we don't really have to say moles per liter or moles over 1,000 milliliters because the unit's the same. All right, it's just going to cross off anyway. So we're going to multiply that by our V1. We have our M2, which is 0.1 molar solution multiplied by 275 milliliters. All right, and again, you guys are going to solve for V1 by doing what? Yeah, so we're going to divide both sides by 6 molar solution, and so our molarity is going to divide out. All right, and so our V1 is what? Say that again.
4.58.
Okay, so we have 4.58 milliliters. And so here's what you're going to do. You're going to take your 4.58 milliliters, all right, and put it into, well, we're going to have a 275 milliliter flask. We're going to fill that half full, put in our 4.58 milliliters of the 6 molar solution, bring the volume up to 275 milliliters, and you got your 0.1 and 275 milliliters. Okay, so a dilution. So what we've gone over, how to make a solution, okay, how to make a certain quantity of a solution, and how to dilute a stock solution, a more concentrated solution, is something that we do on, I can't say a daily basis because we're not doing labs every single day, but, you know, in a chemistry environment, I mean, it's one of the basic things that you do all the time, okay? And pretty simple math to do too, all right? But, you know, we have other things that we can do. We can have a percent, okay, of a solution. And there's 2 different ways that you can do this. How are the 2 different ways that we can figure, or we can make a solution using percents? Okay, so we have by mass, and then you also have by volume. All right, and again, it's just a straight percentage. Now, I think the way that Dr. Lord presents this is he gives you the mass of your solute and the mass of your solution. And that's just straight percent. Mass divided by mass times 100. Or he'll give you the volumes. For me, it's more important that you know how to make a percent solution. Okay. And again, the percent by volume, percent by mass, or yeah, that's right. By volume or mass, very similar to one another. So if we wanted a 7.5% sodium chloride solution, all right, and we're using, okay, the solid sodium chloride, all right. Well, if you have 100, let's say 100 milliliters, all right, in order to find something that's 7.5%, you need what in 100 milliliters? I mean, it's straight percent. So 7.5% is 7.5 in 100, right? So all you would do is take the 7.5 grams of the sodium chloride in 100 milliliters, okay, of your water. Now, you might say, well, that's not grams, all right? That's not 100 grams of water. We know, or maybe you don't, that the density of water is 1 gram, okay? So water, 1 milliliter of water is approximately equal to 1 gram of water. So if I have 7.5 grams of sodium chloride in 100 milliliters or 100 grams of water, I have my percent by mass, okay? Does that make sense? Any questions with that at all? All right, so this right here, you know, is important. This is what I would like you to know. Dr. Lord would want you to do the calculation. So, for instance, if you had 375 grams of a solute, all right, and you have a total of, let's say, 1,200 grams of your solution, what's the percent? Okay, and so what would you do to find the percent? Yeah, you're just going to divide and multiply by 100, right? Okay, so that's how he presents it. Okay, and again, like I said, I want you to know how to do, how to make it, because that's more important. I mean, that's what you're doing in a chemistry lab, is you're going to be making it. The volume, percent by volume, is the same thing. So if we wanted, let's say, 7.5% of a hydrochloric acid solution, okay, you would do the same thing. You could take 7.5 milliliters in 100 milliliters of your water, okay? And that would give you a 7.5% solution of your hydrochloric acid. All right, now, hydrochloric acid is a liquid. So that's why I would do percent by volume with hydrochloric acid and percent by mass with the sodium chloride. Does that make sense? Yeah. So it depends on whether your solute is a liquid or if it's a solid. All right, the last thing would be, where you have your parts per million and your parts per billion. We don't use this so much in chemistry, like accelerated chem really doesn't use that much. But since you're a CCP class, there's different ways, like you can look at the amount of toxins that you have in parts per million or parts per billion. If you see this in literature, or even if I know I saw a news team one time was reporting something in ppms, they had no idea what ppm was, and their writer didn't explain it in the news story, and it was like they kind of looked silly, because they didn't know what it was. But in parts per million, parts per billion, you really do the same thing. It's your mass of your solute, and you're taking this over the mass of your solution. But now you're going to multiply this by 1 times 10 to the 6th, because that's 1 million. In parts per billion would be 1 times 10 to the 9th. Okay. Any questions with that? So let's say we want to know, okay, what is the parts per million if we have 0.00375 grams of carbon dioxide in, let's say, 3,925 milliliters of water. Okay, and so again, you would do the same thing, 0.00375 grams over 3,925 times 1 times 10 to the 6th. Okay, so if it asks for parts per million, you're adding on that 1 times 10 to the 6th piece, okay, in your calculation. All right, any questions with that? And there you go. That's it. Those are the calculations that are associated with this part of the unit, or with this unit. Any questions at all? Oh, what time is it? 11:32. When are we done? 40. Okay, I forgot one part. All right, sorry. But this is like gas laws. This is Henry's law. Okay, in Henry's law, you have a direct relationship between the solubility of a gas and the pressure. And this is S1 over P1 is equal to S2 over P2. Does that look familiar? All right, do you have any questions with that equation? All right, so, and you should be able to solve this kind of equation because you just did this in the last unit. All right, any questions? Do I need to make up a problem and go over it? Okay, we good? All right, so now Ireland, we're done. Okay, all right, so listen, you need to work on your homework. When you come back on Monday, that will be a homework work day for you, unless you have questions. All right, there might be a few things that I want to kind of go over, like maybe unsaturated, saturated, and supersaturated solutions, the colloids and the suspensions. Okay, we'll kind of touch upon that briefly at the beginning of class, and then you'll have the rest of the time to work on your homework test on Tuesday. Okay, any questions? All right.